Okay, so yeah, kind of late night session, but tonight I'm going to work on what is it? Again, working on some of the inference mode code for a model. We're definitely not going to finish it tonight, but going to begin working on some of that because that's kind of important. So yeah, we already do have a branch where some stuff's been added. But first, even before going over that, I'm going to go a brief overview of how this is going to work and what essentially needs to be added. So yeah, I've actually downloaded. So yeah, tonight actually I'm probably going to be doing less coding and more just architecting out stuff on Confluence for kind of documentation and stuff. So yeah, basically though, in its core, inference should be part of. This is part of an overall kind of entire package for like getting models to production and making it easy to use flow forecast in a production setting. So really, this is going to be something we'd like call like productionized machine learning. So I am going to create just a page here. Oh, I probably don't want it to be under there, but I'll change that in a second. It's a good name play. I'll just call it production flow for now. But so yeah, essentially, we're going to just outline basically the goals of what we want this module to do. This is like actually I think an important thing that like particularly more junior intermediate people don't necessarily do enough is really architect out like how something's going to work and before jumping into coding it. And yeah, we do already have some code, but I'm going to kind of formalize it. So basically we want like so we'll start really high level and kind of looking at this and then move down to more concrete stuff. So basically, you fundamentally want a mode to just get predictions. Yeah, so yeah. Let's see. Support getting. So yeah, there are going to be a couple goals. Easily wrap models into standalone services. E.g. Docker containers. Support getting predictions on data and saving predictions saving the predictions to a database or historical archive. Or yeah, probably like a data lake or a bucket. So those are kind of the main goals, and like we can now go into some of the more specific requirements for each and stuff. So big requirement here is we want inference to be meet speed requirements for speed and scaling requirements for a wide variety of problems. Again, I don't exactly know how we're going to do each of these, but we're just kind of looking at how we broadly want them. So, database integration. Support saving predictions to standard databases, e.g. We could just probably say SQL, SQL buckets over. So, and I guess this could kind of be under each. But that's kind of the overall. Oh yeah. I guess another one more is like easy continual evaluation. So as new data comes in, automatically evaluate data, evaluate model on it. Because obviously a big difference between time series and other problems is like within a certain time frame you'll continually be getting data, so you'll be able to continuously evaluate how your model's performing. Identify distribution breakdown. So that's kind of, so let's look at how we're gonna actually go about doing this. So we'll just title this implementation. So basically for bullet points 1, we're going to, in flow forecast, we already have a couple existing classes. It's particularly in the evaluate module. We already have this evaluate module. It's evaluate.py. But the thing about the way evaluate works is obviously but obviously the thing is that like we have like evaluate py is essentially obviously assumes that there's a target too, and there's also other things that we might not necessarily want in it. So, but at its core, I think a lot of the functions are good. So let's actually go into some of those functions and see it. So, but in general, what we always want to do is enable kind of as much code reuse as possible. So we want to just generically have enough generic stuff that we can just import as many functions from that. So I'm just right now kind of laying out where we will probably import functions from. Again, the actual model class, the actual model class will be essentially probably from PiTorch forecast and stuff. So it would be like the time model. So basically, what we're going to do is probably we're going to import probably some functions from here. I'll get into what in a bit, and then basically still have this PiTorch forecast class that's initialized. And then, just pretty much use that to then get the predictions. So we can actually look at some of the code that was already added. I think this is where you push some of it. So this was some of the initial inference code. It looks like a lot of this was just imported directly from the other thing. So, yeah, a lot of these can actually be just blanket reused. This probably shouldn't actually be here, because this doesn't require any of the target values, so this could be directly reused just by re-importing. And then yeah, so then I mean, one of the big questions is, so basically this is just most of the functions were just copied and pasted at this point from verbatim from evaluator. But one of the questions is like, if we're using evaluator, should we just import these and, for instance, try to override the function in evaluator to support both evaluation, inference, or recreate some of the function? And some functions shouldn't need to actually be modified at all. Like I said, these functions that generate the predictions essentially shouldn't need modification at all, and should pretty much be able to be imported as is. So these will obviously be deleted from here in the long run. But then the question is, like, this function, would you want to import it or kind of try to touch up the other function so that it can essentially accommodate both evaluation and inference? And that really comes down to is I'm going to look over in detail of it, like if that would make sense or that wouldn't make sense. So yeah, that's kind of a quick overview of that. We'll continue to lay this out in kind of our documentation. But yeah, the first step is essentially just getting this kind of inference mode working. So we'll still keep looking at high level. Create inference mode. So we're just going to do to create. And so, like, inference mode.py is going to borrow from these two classes. So it's going to borrow probably some functions from this, some functions from that. Definitely more than this initially does. We definitely won't copy all that initially, as I said. And then, this isn't going to necessarily, the inference mode class isn't necessarily going to solve all this individually. So, like, inference mode is just essentially the bare bones class that the model will be getting inference in. To support scaling and other stuff, that's going to be like require more on the architecture side of things, and so support saving predictions to buckets. And then the other big thing, as I said before, is also to actually resume yeah, we also want to, like, just pull existing weights from weights in config and load directly. So basically, I don't know if that's the best place to put that. So yeah, I don't know where to put that, but basically we want to, because, like, assuming people are actually using our configs right, they should be having essentially, I'll quickly sculpt this out, is when they train their model. So when their model is trained, maybe I just put something like integration with training, because, like, when the model's trained, basically weights and the config file and model config are saved to some GCS path, to some cloud storage path. Right now this is pretty much all GCP. This is assuming you save it to it, but even if you don't automatically save it to it, you're probably going to have it be at some path. So we want to handle this automatically. So for instance, it could be GCS, I don't know, we'll just come up with some random bucket, like say like farm yield forecast or something. UUID, and then it would just be basically, well actually you'd have the run UUID, and then you'd have like .json, and then you'd have two of these files. You'd have the .json and you'd have the .path PTH. So basically the idea is what happens is if you want to now use the model in inference mode, you just take essentially all you'd have to pass to this inference py class when you run it would be these two things, and it would essentially initialize the model and stuff. So basically, yeah, you could even just like, so the idea would basically be the entry point would just be something like we would call Python inference py, and just something like, and actually you should only really need to supply this path because the JSON config should contain the weight path. So you would just need to supply, and you probably supply it even maybe as a GCS path, but you'd want to support like both, like something like that, and that's all that it would take for you to reinitialize the model, because using that it should be able to also get the weight path automatically. So that's kind of what the end thing is, and then this thing essentially would then start running. And it would run, and then the model would then just be in effect running kind of online, waiting for predictions. So okay, so yeah, we actually might want to specify other options too. So like this could easily be turned into like a fast API. Isn't that the thing that replaced Flask? I remember there was like something that replaced Flask. So you could like do that with fast API or Flask microservice. Or it could just be like a one, or it could just be like a one-time prediction. So the question is, how's the best way to actually do that? And what exactly would need to be passed to that? So we assume that we just send that and then it starts that up. But then the question is, if we want the similar pre-processing of the data frame to take place in inference, and if like we want the file to be kind of data loaded, would we want to reinitialize the model? Probably not each time, because like for instance, if we are targeting very fast things, just realized people probably have no idea what I'm talking about. But basically, as I said, like normally when training, like when we load the model, that's when the CSV is also loaded and all the proper pre-processing and scaling is applied to that. It's when we load that PiTorch. It's when we call PiTorch. It's actually in the initialization of the PiTorch forecast class. So whenever actually the PiTorch forecast model is called, or I forget what it's actually called, but whenever like the model is the model wrapper class is called, that's essentially when the CSV file is properly loaded and scaled and stuff. So the question here is essentially is in many cases in like production, we wouldn't want to be doing that. We'd want to have the model loaded and then just like have the file like come in and stuff. So that's something to think about. So one-time prediction would probably be fairly easy. We would just like necessarily like specify maybe like a file. Also yeah, we'd have to point because as I said, when the PiTorch, like, I think this is what it's actually called, but I might be wrong. There's this PiTorch forecast class, and basically when it's initialized, it generally expects a train.csv, a validation.csv, and a test.csv. Now, of course, in production, you're not actually going to have those because you're not training or validating anything. But in order for us to reuse that class, we need essentially those things. So the question is essentially how do you do that, or what do you sub in? So I think the answer in this case is that at least initially we could just, like, in our Docker container, have a, say like for purposes a dummy CSV automatically loaded or something. Just for initialization. Because I don't want to override those class attributes, and as I said, if this is running, particularly if this is running continuously, that won't matter, like, because the initialization will still be really quick and this file will be very small. But then the problem becomes, how do you apply the similar type of pre-processing to the incoming file? And so probably I'm probably going to have to look at how it will probably involve, I think, reusing the make data load function. This is, of course, even assuming that the production file comes in a CSV. For instance, like if you're trying to live stream like real-time data in from Kafka or something, then this isn't going to work. Or if like, yeah, you're trying to like connect it to a database, this also isn't going to work. So that could be like future things to support, would be that like, yeah, is where we can ingest data from. So, but I think for V1 we'll restrict data ingestion to just CSV files for simplicity sake. Then like in later versions, like we can support reading from, say, a database, finally maybe reading from a stream sync or some weird shit like that. But we'll assume that essentially then like we would call we'd call this kind of with a CSV file. Okay, so we're getting somewhere. Let me see. Yeah, I don't know. I think. Okay, so I think Fast API now outperforms Slack, so we should Flask. I mean, so we should probably try to write something in that, and write kind of this mode in that. So we'd assume basically though whatever the request would get called with, say, like a path to CSV file. So would be called with a path to a CSV file. So if we just want, now here's the other case where, say we just get some new predictions and we just don't want to run the model, have the model continuously running, but we just want to run it at once. This is actually much easier. Actually maybe create like a section, limitations or something, and put that under there. Support, and then maybe like something like support, just to make this clear. Could be one-time prediction. So this is much easier. So we basically then, if that's the case, we would just swap CSV. Remember, like, so here we had a dummy path, but so here we just swap CSV path and params. And indices with so in config with new file path / indices. So the way I think for this initial config here, you would maybe then have one more param. We just call it like the mode thing. You could put an M for mode, and so this would be, and so the options here, you might do something like API, or single, and then and then if it was single, then you'd also do something like your start index. So that would just be the start index, and then this would and then something like start index. So that's pretty much what you would do. And so yeah, just to clarify, like, new path would only required in single mode the path to the CSV to perform inference on. And then the start index would just be the index that you want to start, because like someone might have a CSV with kind of other stuff and they just want to start. Okay, so yeah, that's kind of the outline of that. I think this makes sense. So yeah, this kind of gives me a better idea of how to actually outline it. It also provides, I'm also essentially writing documentation as I go, so people will have a good idea of like what it's actually doing and what we're supporting and not supporting at the moment. Do I want to add anything else right now? So yeah, I think that's a good thing. And then so people, as I said, like they call it with the existing path, and then like one of these things, and then what else? They call it with the existing path, and then like yeah, and then just either what mode they're using, either API or single. And then in the case that they're using single, they'd have to supply the path to the new CSV they want to use and whatever start index they want to use. Okay, so that's basically what we do, what needs to be done. So okay, so let's see. So yeah, as I said, I think this one will definitely be easier initially to implement. But they'll all still use this like the same core functions. This one is just going to be a little different because we'll have another class even that takes a request and kind of wraps that inference module. Wraps the inference module. Yeah, so there'll be like an actual like inference module too. Probably one that just takes the CSV path and runs the stuff on it. So there probably will be like an infer within this, like an infer function, and then like but then there'll be like the main thing, of course, and the main will launch the API, which then would call the infer function, and the other like it will just initialize the model and then call the infer function and do that kind of CSV replacement. So I think that's basically conceptually how it will work. Again, what should I do? Implementation. Maybe do like okay, yeah, maybe then have, when I get some examples, I'll like actually put them there. Okay, so, and then yeah, definitely for future versions too, I think we'd want to support more stuff, but just gonna write like what I hope to add the loading data from databases for inference. Or streaming sync. So yeah, there's different ways of doing this. That would be really important for real-time inference. But yeah, as I said, not going to deal with that now, because that's substantially more complicated. So, but this is kind of the layout plan. I guess this could be really any future version. The core is just to get this inference mode kind of working and supported with stuff and dealing with the and kind of laying out stuff. Here's where too, like if we were doing something like Scrum, which I don't like, where we might break it down into stories, but I'm going to outline this into issues. So I am going to just outline into basic issues though. So issue, might do like an issue breakdown, something. So, or I don't know. I'll just make a list here. One, we want to support automatically loading. This is really something that should be useful anyways, even if you're training. Loading weights from a GCS path. Each of these I'm envisioning will probably be its own separate PR. Support automatically loading weights from GCS path. 2, we want to create generic run infer CSV function, which would take a existing model and take an already initialized and run inference on its CSV file, and this would already assume that the CSV file has been been loaded properly into the data loader. So create inference function. Determine reuse code where possible. Create fast API stuff, wrapper class, and figure out how to properly process incoming CSV from request. Create function to swap in config of the model for single inference. Package it all together in a flow infer Docker file that would use as an entry point. I think that's the basic stuff. So yeah, I hope people found that useful. I'm going to... How do I move this to another thing? I'm actually going to... I want this to be its own page. Or I don't know. Where's that? Ah, crap. Where do I go back to the original one? I'll just publish it here for like right now, and then I think I can just move it. So I think I can move it like here. So, okay, so there it is. It's like kind of what we want to do and stuff. So, yeah, as I said, not much coding this time, but this architecting stuff's really important before you jump into coding, because it can save you a lot of time from like coding some shitty design that you should never have started on in the first place. And in theory, yeah, if like if this was a real thing, well, I mean, if I had more people around, I would definitely run this usually through an architecture review meeting, where we just review this and like review some of the assumptions I make. I don't have too many other people to review this by, but I probably will post it to our Slack group. But yeah, in general, for most of this stuff, like you'd want to run this by an architecture kind of review with your team. But yeah, you might like, yeah, just put in like a couple more words about like, we want to make it's simple for flow forecast for data scientists and DevOps people to take flow forecast models and integrate them into production business applications. That would kind of be just the statement. I don't know what are DevOps. I guess DevOps engineers or something. Production business applications, as well as, what was it? Didn't we want to do something else? Oh yeah, as well as gauge, as well as facilitate model retraining and continued monitoring of performance in production. On that same note, we probably want to eventually figure out a way to like continuously get those SHAP plots and other stuff. I know those are being essentially plotted and saved to weights and biases at the moment for evaluation, but in theory, in a production application, you'd probably want, I guess we could use weights and biases though, right? Yeah, I don't know. I don't know if you'd want to use weights and biases or construct your own dashboard feature for actually monitoring like real-time production stuff. Yeah, I have no idea what their latency and stuff is. But in some way, you do want to obviously show the interpretability stuff in the production context too, because you definitely have people like probably wanting to know why it's doing what it is on the production side, just like in the evaluation side. production flow. See, this would actually be... Oh, I might just actually switch to calling this peel out. I still love that idea. Peeling out into the flow. You know, when you're paddling, a lot of this still gets like its name from its paddling stuff, but you're paddling and you're like in an eddy and you're about to run white water. The move you do is usually called a peel out, because you'll have like the nose of your bow facing upstream, and like you'll turn out of like the eddy into the you know, the current or the waves or the white water, and you'll just like hold your paddle kind of sideways and just let the current turn your boat, and sometimes you'll even push off and get a power stroke of that to like begin kind of a downstream ferry across the white water. But anyways, that whole maneuver is called a peel out, because you're essentially peeling out of the eddy into the current. So the whole it's kind of a joke when this thing was, I called this thing flow forecast. I was thinking of other names to go with stuff. So peel out was kind of an idea, kind of just to play on this. Outlines, getting outlines, how to use your models in production, as well as our own internal design process for forecast production. Peeling out. I'll just call it peeling out. To enable you to smoothly peel your model. Something like that. Okay, so done making whitewater puns now. Okay, so yeah, that's kind of the core. Yeah. Oh crap. So yeah, that's kind of the design process. It's getting late, so probably not going to do any more now, but I'll be back tomorrow to actually implement and design some of this stuff.